Hey guys, in this video, we can discuss Leetcode 1937, the maximum number of points we can collect with the cost. So basically for this problem, we're gonna be given a grid of points, and we're gonna start from the first row and select one cell, and then move to the second row, select another cell to collect the points. However, there will be a cost when we are selecting cells. So basically the cost will be the number of columns we move. So for example, let's say example one. So let's say we want to maximize the points we collect. So for first row, we collect the cell 3. And then for second row, we collect cell 5. However, there will be a cost of 1 because we move by one column when we are moving row 1 to row 2. So there will be a cost of 1 because we moved one column. And then from row 2 to row 3, we moved by another column from 5 to 3. So there will be a total cost of 2 columns. So the total points we can have will be 11 minus 2 will be 9. So basically, for this problem, we're gonna use dynamic programming for that. So and we can move either like to the left or to the right when we are moving columns, right? So we can use a dynamic programming and then to check like both directions of moves to see how to maximize the maximize the points we can collect. So let's start with this example. So let's say the input will be the same as this one, example one. And we initialize the DP grid by 1, 2, 3 as well, because so the first DP row will be the same as the input row, because this is like the 1, 2, 3 points we can collect, and then the DP array will be 1, 2, 3. All right, now then let's go to the second row. So for second row, which first of all, like how much cost we can get by selecting the different cells in the second row. So because the cost will be like the number of columns we move. So let's say like if we move from left to right, and like if you like we move from left to right, and let's see how many points we can get from the first row. So give me a second. So let me just say 1, 2, 3, right? So if we move from left to right, so let me see. So here, like the initial, if we like move from this cell, right? We only consider direction from left to right, then this cell will still have a value of 1. And for the second cell, it will be the previous cell minus 1, the maximum of the current cell, like moving downwards, there will be no cost, plus against the previous cell minus 1. So basically, let me just write it down. So it will be the max of dpj plus and the dpj minus 1 minus 1, dpj minus 1, the previous cell, and minus 1. So this will be maximum of 0 and 2, so it will be still 2. Then this one will be the maximum of 2 minus 1 and 3, so which will be 3. All right, so this is how we do it left to right. And for right to left, it will be similar. So initially, let's set it to 1, 2, 3 as well. So now we can start from the leftmost position, which will be 3, right? So the second, so this position will be the value for this position will be it will be the same. So the max of dpj against dpj plus 1 minus 1, j plus the next column and minus 1, because there will be a cost of 1. So it will be maximum 2 and 3 minus 1, which is still 2. And here it will be the same. So it will be the maximum of 1 against 2 minus 1. So it will be still 1. All right. So now this is the values we can get, right? And how do we define the dp value? So dp value will be for this cell, right? It will be the value of this cell plus the maximum of this one and this one, either move from left to right or right to left. So let me just also write it down here. So it will be the maximum of input of j plus the maximum of left to right j and right to left j. Just give it more space and see how it goes. Yep. All right. And okay. So now, so this one will be 1 plus maximum of 1 and 1, so it will be 2. This will be 5 plus maximum 2 of 2, so which will be 7. And this will be 1 plus maximum 3 of 3, so which will be 4. All right. So now let's do the third row. So now we can calculate 2, 7, 4, right? 4 left to right and right to left. So for the first one, it will be the maximum of, it will still be 2, right? It doesn't move. And then for this one, it will be the maximum of 7 against 2 minus 1. So 2 minus 7 against 2 minus 1, right? Which will be 7. And then this one will be 4 against 7 of minus 1, so which will be 6. Here this one 4 will unchanged. And then here will be again 7 against 4 minus 1, which will be 7. And here it will be 2 against 7 minus 1, which will be 6. All right. So now the new value here will be 3 plus maximum of 2 and 6, so which will be 9. And then the value here will be 1 plus the maximum of 7 and 7, which will be 8. And then here will be 1 plus maximum of 6 and 4, which will be 7. All right, so this is the last row for the DP we can get. And then what we need to return is just return the maximum of the last row, which is 9. So that's what we need to return. Okay, so basically this is the algorithm we're going to use, and then let's try to code it out. So let me just minimize that. So let's see how it goes. Okay, so now we need to get to the size of the grid first. Rows will equal to the length of the points. And we just initialize the DP array and look through the, let's initialize the first row to the same as the first row in the points. Of columns will equal to the length of points. And then let's initialize the DP array to 0 times number of columns for every row in range. All right, so this is a DP array, DP grid, sorry. And then we initialize the first row in the DP grid to be the same as the points, right? So for I, the value enumerate the points, first row of the points, we just initialize the DP, sorry. Initialize the DP 0 I will equal to the, right? So we initialize the DP grid. Now we just loop through the starting from the second row to loop through the grid, the points grid. So for I in range, so the second row to number of rows. So the pref dp will equals to dp I minus 1. So now we just need to calculate left to right and then right to left. Yeah, left to right and the right to left. So left to right would equal to the same. Let's just make a copy of that. And the right to left is the same. Now we just need to calculate the left to right and to left. So for j in range columns, so because the first item doesn't change when we do the left to right. So left to right would be max of dp to this one, right? Sorry. So left to right, a equals to the maximum of this one to this. Yep. Now we need to do the same for the right to left. So right to left, we're gonna just loop the other direction. We're gonna skip the last column, so it should be -2. Yeah. So right to left. Here should be +1. Now we need to calculate the dp array. Yeah, it should be this one. Yeah, I made a mistake here. It shouldn't have max. So it should be the same. For j in range, this one should be columns because we need to starting from calculating the first cell. So the dpij row, the column equals to the points ij plus the maximum of left to right and right to left. And then lastly, we can just need to return the maximum of the dp, last row in dp. So I think you'll see how it goes. Yeah, looks good. All right. So yeah, so this is the basically the algorithm we're gonna use. So DP approach, and the time and space would be both would be n squared, so like the size of the grid. So yeah, this is the end of the video, and I'll see you guys in the next one.